Welcome to Function Focus Lesson 27 with Ms. Barrett. I hope everyone was able to have a good holiday weekend and that you're refreshed and ready to learn. So, last week we discussed multiple things about exponential functions, okay, including how to graph them. So, this week, because we had a Monday off, I didn't want to go over new information, but I wanted to actually just really get you good in your skills with graphing exponential functions. So, if you remember, all exponential functions can generally be represented as f of x equals a times b raised to the power x minus h plus k, okay, where a represents the y-intercept, b tells us whether it's a decay or growth, h, which is in the exponent always, tells us a shift left or right, and k tells us a shift up or down. Okay. I also wanted to make a reference to just make sure that you know if a is negative, if you have negative a, that represents a reflection across the x-axis. That's another transformation. So really, when we're thinking about our transformations, we're thinking about the a value. If it's negative, then we know we have a reflection. The h value is the opposite of what you see, and it tells us a shift left or right. And the k value tells us if we're going to go up or down. Okay, so let's look at number one. If I give you a function and I say graph it, an exponential function, I say graph it, f of x equals 2 times 4 raised to the x minus 2 power plus 1. And I say graph it. The first thing you're going to do is you're going to identify your parent function. And the parent function is the function without shifts. So it's the basic. It's just a times b raised to the power of x. Okay, a positive a times b raised to the power of x. So if we look here, what we're going to do is we're going to check to see if our a value is a negative, and no, it's not. So it's positive 2, so it's nothing we have to do with our a value. But we're going to take our fingers, we're going to cover up the h and the k. Okay, we're going to cover up h and k because those represent shifts. We don't want the shifts. We just want the parent function to be the function without shifts. So if you see here, when I cover that up, I get 2 times 4 raised to the power of x. That is our parent function. That's it. Our parent function is that simple. It's the function without shifts. Okay? Now, once you identify your parent function, you're going to plot the points for your parent function by plugging 0 in for x and then plugging 1 in for x and getting out your y. So we're going to plug in 0, 2 times 4 raised to the power of 0. Again, we're plugging in these values into our parent function. So 2 times 4 raised to the power of 0, if you put that in your calculator, then you're going to get 4 raised to the power of 0, because you have to do your exponent first, which is 1. Okay. That's going to equal 2 times 1, because anything raised to the power of 0 is 1. So 4 raised to the power of 0 is 1, so it's 2 times 1, which equals 2. Okay. So here you're going to put 0, 2. That's your first point in your parent function. Your second point, we're going to now plug in 1. 2 times 4 raised to the power of 1. All I do is plug it in. Plug in 0, plug in 1. That's going to give me 2 times 4 raised to the power of 1. 4 raised to the power of 1 is 4. That's 2 times 4, which equals 8. So now I have my points to plot my parent function. Okay. So now we're going to graph the parent function. We're going to lightly sketch the parent function, right? We needed the points to lightly sketch the parent function. So the first step was to identify the parent function, then plug in 0 and 1. That's all we've done so far. Now we're going to go to our graph, and we're going to plug in, lightly sketch that. So I'm going to go to 0, 2, and I'm going to go to 1, 8, and I'm going to lightly sketch my parent function. Now, we know from this b value, which is 4, that this is going to be a growth because it's greater than 1. So we know that from as x approaches positive infinity, f of x is also going to be approaching positive infinity. So it's going to be going up like this. Okay, let me fix that so that you can see that it's going through these points. Yep. Okay, so this is our function, parent function 2 times 4 to the power of x. We just sketched that, and that's sketched in pencil. Now I'm going to sketch the function with the shifts in a different color. So now, once you have identified and graphed your parent function, you can now identify, look at your actual equation and identify your shifts. Okay. Let's identify our shifts here. We have 2 times 4 raised to the power of x minus 2 plus 1. So our a is positive. Our h is the opposite of what we see. So since it's x minus 2, then h is going to be 2, positive 2. And our k is going to be positive 1. So h is positive 2. K is positive 1. So since h is positive 2, that means we're going to go right 2. And since k is positive 1, that means we're going to go up 1. And then the question is, do we have a reflection here? And the answer is no. Because the a is positive, it means there's no reflection. There's only a reflection when a is negative. So we identify our a, h, and k, and we said, okay, we have to now shift right 2 and up 1. Okay. Right? Now, what is our domain, range, and asymptote? Looking at our equation. Well, our domain is always all real numbers. And this is for the new function when we shift it. Our domain is all real numbers. Our range and our asymptote always deal with the k values. Our domain and asymptote always deal with k. So our asymptote is going to be y equals k. So it's going to be y equals, and k was 1. And then our range, if it's a growth, it's going to be y is greater than, and if it's a decay, it's going to be y is less than. So since it's a growth, it's going to be y is greater than 1. Now we've identified everything we need to know. We know our shifts and we know our asymptote, which is what we need. We're going to go ahead and we're going to graph it. So this is our parent function without the shifts. So now what you're going to do is, I advise that you take your asymptote and you draw your asymptote. So your asymptote is y equals 1, which is right here. This line is y equals 1. Means your graph is going to be approaching, your new graph is going to be approaching that. So now we're going to take each of our points of our parent function and we're going to shift it the way that we said that we needed to shift it. So we're going to shift it, each point to the right 2 and up 1. So each point is going to go to the right 2. So this point was originally 0, 2. I'm going to go to the right 2 and up 1. And then I'm going to go to the right 2 for this one and up 1. And these are our new points. Okay, and these are our new points. So now I know that my graph is going to be approaching this asymptote y equals 1. Okay, and now in purple, this is the function f of x equals 2 times 4 to the power of x minus 2 plus 1. Okay. I just took each of my points and I shifted them how the equation told me to shift them. And I identified my asymptote. All right, let's do it again. I almost dropped you guys. Let's do it again. I have here -3 times 2/3 raised to the power of x plus 1 plus 3. Okay, first thing we're going to do is we're going to identify our parent function. So we need to cover up all of our shifts. So I'm going to cover up the h in the exponent and the k. And then if you notice here, the 3 is negative. That means the a value is negative. That negative represents a shift. So I'm going to cover that up as well. So what I'm left with is 3 times 2/3 raised to the power of x. Okay. 3 times 2/3 raised to the power of x. Okay. Again, you cover up all of your shifts. Now that I have my parent function, which is just ab to the power of x, positive ab to the power of x, I'm going to plug in 0 and 1. So 3 times 2/3 raised to the power of 0. Okay, do your PEMDAS to simplify it. I start with my exponents. 2/3 raised to the power of 0 is 1. And you can put that in your calculator. So you get 3 times 1, which is 3. So the point is 0, 3. Now I'm going to do the same thing with 1. Plug it in for x. 3 times 2/3 raised to the power of 1 equals, so 2/3 raised to the power of 1 is 2/3. You can put that in your calculator as well. So you get 3 times 2/3. Now, when we discuss series, we learned that when you're multiplying by fractions, you have to multiply across. And also remember that any number, any whole number, any integer can be represented as a fraction over 1. So 3, number 3 is really a fraction 3 over 1. So we're just going to multiply across. So 3 times 2 equals 6. And 1 times 3 equals 3. And then we can simplify this because 6 and 3 both have a factor of 3. So 6 divided by 3 is 2. And 3 divided by 3 is 1, which is just the number 2. Okay, so now I have the points 0, 3, and 1, 2. So I'm going to sketch my graph. So after step 2, it says 6, 7, and 8. Well, after step 2, this is when you're going to graph the parent function, okay? So I'm going to go ahead and graph it using these points. Go ahead and graph it using these points 0, 3, and 1, 2. 0, 3, and 1, 2. Now, if you look here, ladies and gentlemen, this graph is going to be a decay. Why? Because my b value is less than 1. Okay, which means that as f of x, as x is increasing, as x is getting bigger, f of x is going to be getting smaller. So the graph is going to look something like this. Trying to make it as neat as possible. Okay, so this is the function 3 times 2/3 raised to the power of x. And we know it's a decay, so that means as x gets bigger, f of x is getting smaller because the b value is less than 1, which is 2/3. All right, now that I have graphed my parent function, I'm going to go ahead and I'm going to now identify my shifts by looking at my equation. So my h is the opposite of what I see. So since it's x plus 1, h is actually negative 1. And my k is exactly what I see, which is positive 3, so k is positive 3. So since h is negative 1, that means I'm going to go left 1. And since k is positive 3, I'm going to go up 3. Okay. And do I have a reflection? Yes, I do have a reflection. Okay. Because my a value is negative, that negative tells me that I must reflect across the x-axis. Okay. So I have 3 shifts here. 3 shifts here. What I will tell you is always do reflection first. Okay? It's not a rule. You don't have to always do reflection first, right? You can do your H and K shifts first. But me personally, I feel like it's been easier for my students to do the reflection first and then do the H and K shifts. Okay? So we know what our shifts, our transformations look like for our new exponential function. Now, our domain is always all real numbers. Our range and asymptote both deal with the same value, which is the k value. So since k is 3, our asymptote is going to be y equals 3. And since it's let's figure out our range. Because what's going to happen is our range is going to change because even though this is a decay function, it's also flipped across the x-axis. So before you do your range, if you know that you have a reflection, do graph the function first and then find your range. Okay. So now looking here, we need to reflect across the x-axis, then we need to go left 1 and up 3. So let's do that. First things first is your reflection. We're going to take each of our points and we're going to reflect it across this axis here. We're going to reflect it across this x-axis. So that means our y values will change. So this first point was the point 1, 2. So now if we're going to reflect it across the x-axis, the point is going to be 1, negative 2. It's like looking in the mirror. So this x-axis is a mirror, and if this point 1, 2 is looking in the mirror, then it becomes the point 1, negative 2. Then we're going to take this point 0, 3, and we're going to make it 0, negative 3. Okay, so these are our reflected points, and this is what the reflection would look like. I'm no Picasso, ladies and gentlemen. Okay, so this is what our reflection would look like. Again, it looks like we're looking in the mirror. This original parent function is looking in the mirror at this reflected function. Okay. Now, this is not done. We're not done. This is just a reflection. Now we have to take these reflected points and move them to the left 1 and up 3. So I'm going to take these 2 points, this point here, 1, negative 2. I'm going to go to the left 1 and up 3. So I went to the left 1 and up 3. And then I took this point 0, negative 3, and I'm going to go to the left 1 and up 3. And now in purple is my new exponential graph with the shifts. Okay. And it's going to look a little something like this. Okay. Now, it's the asymptote we said was the line y equals 3. And that line is right here, which means that the graph is going to get really close to that line, but not touch it. Okay? That's our asymptote. Now, if we look at that, we see that if we said that the range has to be the same number as the asymptote, what's happening to the graph? Is the graph above 3 or below 3? Well, as you can see, because it's a decay, it's going to be below 3. So its y is less than 3. Okay, so now our range is y is less than 3. And we can see that from the graph. If our asymptote is y equals 3, the graph is below 3. It's not above 3, it's below 3. So again, let's recollect what we did. We first identified our parent function. We then plugged in 0 and 1 to plot points for our parent function. And then we plotted it. Next, we looked at our equation here, our exponential equation, to identify our shifts. For this specific equation, we had a reflection, a shift left 1, and a shift up 3, denoted by the a value, the h value, and the k value. Once you identify those, you can identify your domain, range, and asymptote. Now, because this had a reflection, you had to wait to find your range. So I would suggest that you graph the function, the function with the shifts before you decide your range. Okay, and remember, your range and your asymptote are both the k value. So whatever the k value is, your asymptote is going to equal k. Your range is either going to be greater than or less than k. So once we found out our shifts and we identified it was a reflection, a shift left 1 and a shift up 3, we took our parent function points and we first reflect. So remember, reflect first. If there is a reflection, reflect first. So we took the points and we reflected them. Then we took each point and we went to the left 1 and up 3. And that gave us our final, in the purple, our final graph. Let me write what it is. Our final graph is -3 raised, times 2/3 raised to the power of x plus 1 plus 3. All right, for your practice, it's going to be the same thing you have to do for each problem, except for, of course, it's different numbers. So if you need assistance with the practice, okay, you can watch this video, look at these notes. You can also email me if you have any issues, or send me a comment on Google Classroom. I would actually prefer you send a comment on Google Classroom, because if you have a question, it's possible that your other classmates may have a question, and then I can answer it for everyone on Google Classroom. Hope you all have a wonderful day. Bye.